Force and pressure.
Turning effect of force.
A force is a push or pull upon an object by the interaction of another object. Force is needed to change the transitional state of a body. But what is the analog of force in case of rotational motion? To look into the question, let us take the example of opening or closing of a door. A door is a rigid body which can rotate about a fixed vertical axis passing through the hinges. What makes the door rotate? A force applied to the hinge line cannot do the job, but a force of given magnitude applied at right angles to the door at its outer edges is most effective in producing rotation. It is not the force alone, but how and where the force is applied is important. Thus, when an external force acting on body, it has a tendency to rotate the body about a fixed point, it is called turning effect of force or moment of force or torque.
Calculation.
Moment of force or torque is measured by the product of magnitude of force and perpendicular distance of the line of action of force from the axis of rotation. It is denoted by, mathematically, torque is equal to R into F is equal to RF sine theta n, where theta is smaller angle between R and F, n is unit vector along torque, is equal to 0. When is equal to 0? Max. When is equal to 90 degrees. That is equal to max value. Pressure. When a body is placed on a surface, it exerts a force equal to its weight on the surface. The force acting normally on a surface is called thrust. The thrust acting per unit area of surface is called pressure. Thus, pressure is equal to thrust divided by area. To understand pressure, consider an example. Example: suppose you have to carry a heavy packet. If it has strings to carry it, your hand is hurt. But if it has wide handles, you feel comfortable. In a short while, strings start to hurt your hand. Both the string and handle exert a pressure on your hand. However, the pressure of the string is much greater than the pressure of the thick handle. This is the reason why the string quickly starts to hurt you. The force or the weight of the packet is the same in each case. However, because the string is thin, the area of contact with your hand is very small. This means that the pressure is very large. The handle covers much greater area of your hand. So, the pressure is less. Unit of pressure. Pressure is equal to thrust divided by area. In the SI system, the unit of force is Newton, N, and that of area is meter square. So, the unit of pressure is N divided by m square. This unit is also called Pascal, PA. Pascal, PA is equal to Nm raised to the power minus 2. We conclude that 1. The pressure is directly proportional to the thrust, which means the greater the thrust, the greater is the pressure. 2. The pressure is inversely proportional to the area on which force, thrust, is applied. The lesser the area in contact, the greater is the pressure. Examples involving pressure. 1. Army tanks are usually very heavy and therefore exerts a lot of force on the ground. Hence, they are made to move over broad steel tracks rather than on wheels, as broad steel tracks increase the area of cross-section in contact with the ground and so pressure is reduced. Thus, the movement of tanks becomes easier without their sinking into the ground. For the same reason, Caterpillar tracks are provided with 16 wheels and more to increase area in contact. 2. Heavy trucks have 6 to 8 tires instead of the conventional 4. This is done to increase the area of contact between the tires and the road, because of which the pressure on the ground is reduced. 3. Base area of a high tower or a tall building is quite large, so that ground is able to withstand the pressure of the building. 4. Animals like camel can walk easily in a desert as compared to horses because camels have broader feet. The broad feet exert less pressure on the sandy ground. Pressure exerted by liquids. A liquid contained in a vessel exerts pressure at the base of the vessel due to the weight of the liquid and exerts pressure on the wall of the vessel due to collision between the molecules of the liquid and the vessel. Since the molecules of a liquid are continuously in motion, so they strike regularly with the walls of the container. With every collision, these molecules exert a thrust on the walls of the container, thus exerting a pressure. 1. Pressure at the point depends on depth. Activity. Take a container made of tin. Drill small holes at 3 various heights of the container, one below the other. Put water in the container and open the holes. You will observe that water rushing out from the lowest hole goes farthest. The water falling from the highest hole falls at the nearest distance. This indicates that pressure of water near the base of the container is maximum. Hence, we conclude that pressure depends on depth and it also increases with depth. 2. Pressure of a liquid is same in all the directions at a given depth. Activity. Take a tin can, drill holes around it at the depth, put water in it and open the holes. You will notice that water is coming out from the holes with the same speed and falling at same distance. This shows that a given depth pressure of a liquid is same in all. Hence, we conclude that a given depth the pressure of the liquid is same in all directions. 3. Liquid pressure depends upon the density of the liquid. Activity. Take 2 identical glass tubes open at both ends. Put rubber balloons of identical size at one end of each tube. Pour water in tube X and kerosene in tube Y. The volume of both the liquids should be the same. You will observe that bulge in tube X inflates more than the bulge in tube Y. This occurs because density of kerosene is less than the density of water. Hence, we conclude that liquids with higher density exert more pressure. 4. Liquid exerts lateral pressure on the sides of the container. Activity. Take a metallic tube with a small opening near the base. Tie a rubber balloon to the side opening and put some water in the tube. You will observe that balloon starts inflating as you go on increasing the amount of water. This is due to the fact that liquid applies pressure on the side walls also. This shows that liquid exerts lateral pressure on the sides of the container. The lateral pressure is exerted by the liquids and gases but not by solids. Transmission of pressure in liquid. The transmission of pressure in a liquid was first observed and established by Blaise Pascal and is known as Pascal's law. According to Pascal's law, when pressure is applied on a confined mass of liquid, it is transmitted equally and undiminished throughout the volume of the liquid. It acts at a right angle to the walls of the container.
This can be demonstrated by this activity.
Activity. Take a long glass tube having a small piston at one end and a round bulb at the other. The round bulb has some holes in it in different directions. Fill the apparatus with water and press the piston. You will observe that water comes out of all the holes with equal pressure. Pressure exerted by gases. Atmospheric pressure. The layer of air around the Earth is called atmosphere. As we gradually move up, the density of the layers of air continues to decrease, and at a particular height, this density reduces to zero. Beyond that, there is no atmosphere. Anything that has mass will exert force. As we know that air also has mass, so it exerts force, thrust, on the Earth's surface and on the objects. This thrust acting on unit area of the Earth's surface and on all the objects on or near the Earth's surface is called atmospheric pressure. In SI system, the value of atmospheric pressure is 1 lakh Newton per meter second or 1 lakh Pascal. This is a tremendous amount of pressure. Our blood pressure balances this high value of atmospheric pressure. To prove that air exerts pressure, let us perform an activity. Activity 1. Take an empty tin can. Put some water in it and heat the can. The water will boil. When entire water boils and some steam escaped into the atmosphere, put an airtight cap onto the tin. Now, pour some cold water onto it. The remaining steam will condense into water and partial vacuum will be created inside the can. Due to high atmospheric pressure outside, the can will crush. This shows that the air exerts pressure. Activity 2. To show air exerts pressure. Take a glass tumbler and fill it with water. Now place a cardboard on the tumbler and press it on the mouth of the tumbler so that there is no air left inside the tumbler. Hold the tumbler in the hand and invert it upside down as shown in figure. Observation. When cardboard is released free, it does not fall because water exerts pressure to the downward direction and atmospheric air exerts pressure in the upward direction, which is much larger than the pressure of water.